Good afternoon for class 10 students. Hope doing well. Um, so uh, as I already told you, be focused on your studies. No more distractions. No deviation. Means do not deviate from your studies. Focus only on your studies, right? Because class 10 means not it is a single year, not a single year effort. It is a 10 plus 10 or more than 10 plus years effort. So keep in mind this and be focused on your studies. Read your textbook, underline some points, note down some points, any formulas, problems should be practiced, right? Practice the diagrams properly. Practice the diagrams properly, then you will understand the concepts very well. Otherwise is a difficulty. So please do not waste your time. Focus on your studies. Do not deviate. Do not deviate. No more distractions. And don't confine on your what your teacher is saying or explaining in the classroom. You must utilize the time properly. You must read your textbook. You must note down some points. You must practice the problems and diagrams, whatever. Follow the instructions given by your teachers. Okay. Then next topic is image formed by a spherical mirrors. Image formed by spherical mirror. Image formed by spherical mirror. As we already discussed how the images are formed, by a plane mirror. How the images were formed by a plane mirror. So let us discuss how images are formed, how images formed by a concave mirror. For that, we need to draw or practice some rules. We need to practice some rules how to get a image, how we get a image by a plane mirror. As we discussed earlier, principal axis, focus, focal length, aperture, pole, radius of curvature and center of curvature. Then class 10 children, you are not all watching my videos properly. In other class 8th and 9th students maximum are watching at least 10 to 12 members, but class 10 children are not all watching, right? Okay, due to your busy time. So I know your time, I know your busy time, and I know your opinions, I know your that means your requirements, whatever. In case of if you are free, now maybe you are free until this month, at least this time you have to focus or watch my videos. Old videos you have to watch instead of new one, right? Okay, whatever. So rules obtaining images formed by a concave mirror. Rule 1. What is this rule 1? Rule 1. Rule 1. Rule 1. So, if a ray of light which is parallel to the principal axis, rule 1 is rays of light or rays of light are parallel parallel to the principal axis. Principal axis. That means what happened if what happened if parallel light rays, if the light rays are parallel to the principal axis. What happened if the light rays are parallel to the principal axis? So we know, imagine that a concave mirror, the line joining to the pole and the pole and focus, we can call it as the principal axis. So if it is the principal axis, if the light rays are parallel, if the light rays are parallel to the principal axis, what happened if the light rays are, if the light rays are incident parallel, light rays incident on the mirror, on the concave mirror. So concave mirror, principal axis. So this is the pole. So here it is focus, here it is center of curvature, center of curvature. So a concave mirror, a concave mirror, concave mirror, parallel rays. At least to explain the formation, to explain the image formed by a mirror, we require at least two light rays. We require at least two light rays. We require at least two light rays. Two light rays are required. So first light ray, second light ray. These are parallel to the principal axis. Parallel to the principal axis. What happened after, if they incident on the, if they incident on the aperture or on the plane, on the concave mirror, on the concave mirror, after reflection they passes through the focus, they passes through the focus. So if the parallel beam of light, the parallel beam or the parallel light rays are incident on the mirror, on the concave mirror, these rays are parallel to the principal axis, parallel to the principal axis, then what will happen? They meet, or they, after reflection they passes through the focus, passing through the focus. So those light rays which are parallel are close to the principal axis, are close to the principal axis, we can called paraxial rays, we can called paraxial rays. The rays which are parallel and close to the principal axis. Close to the principal axis, we can call paraxial rays. So, if the parallel light rays are incident on the reflecting surface of concave mirror, after they reflect and passes through the focus. Passes through the focus. This is the rule 1. This is the rule 1. Then rule 2. If light rays are parallel to principal axis, then rule 2. Rule 2. If the light ray or ray of light passing through focus, what happened if the light ray is passing through focus? Light ray is passing through the focus. Okay. Second case, concave mirror, principal axis, this is pole and this is the focus, then center of curvature. So concave mirror. If a light ray is passing through the focus, if the light passing through the focus after incidence, it reflected parallel to the principal axis. So here this is a incident ray and this is a reflected ray. This is incident ray and the other one is the reflected ray. Right? So this is the second rule. Similarly here, principal axis, parallel light ray. So this is our. Then rule 3. Next one is rule 3. Rule number 3. If the light passing through center of curvature, what happened if the light passes through the center of curvature? So concave mirror. So drawing diagrams are the very, very important. Right? We should draw diagram correctly. We practice the diagrams. Principal axis. Pole. Here it is the pole. Let us consider focus, and the third, it is the focus, and here the center of curvature. C means center of curvature. So C is equal to here center of curvature. F is equal to focus or principal focus. P is equal to pole. If the light ray is passing through center of curvature, passing through the center of curvature. So draw diagrams very concentrately, otherwise we did not get the proper position of image. If the light ray passing through center of curvature, after reflection, it move in the same direction. It reflect in the same direction. Reflect in the same direction because of here. What is the center of curvature? The center of the sphere. The center of the sphere is called center of curvature. Why the light ray is reflected along the same direction of incident ray? Because of this line is acts as a normal. This line acts as a normal. So the other one, center of curvature, means the converging point of the converging point of normals, the converging point of normals of a concave mirror, of a concave mirror. That means, let us understand, if it is the circle or a sphere, it is a sphere or the circle, right? So center, so it is a radius, it is a radius, radius of sphere or radius of circle, radius of circle. So in this case you have some mathematical knowledge about tangents, about tangents. So in case of spherical mirror, either concave or convex, so if we cut into half, we cut into half, then what will happen? It forms a bent in surface or bent out surface. Let us consider this is a concave surface. Concave surface. So whenever we draw some lines like this, some lines on the each point, each and point of circle or sphere, only one line touches the, only one line touches the point of any, touches the one point on the circle, touches only one point on the circle. When we draw the lines like this, when we draw the lines like this, one, like one line touches the only one point of this, one point on the circle. That line is called as a tangent. That line is called as tangent. So this tangent is perpendicular to the, this tangent perpendicular to the radius, perpendicular to the radius. So the tangent and the radius of sphere or the circle, both are perpendicular to each other, perpendicular to each other. So if it is a concave surface, if it is a concave surface, then here it is the center of curvature for this point, right? Then similarly, for this point, one tangent. 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 So, these all are all are converging at the one point. So this radius is perpendicular to this tangent. This radius perpendicular to this tangent. Then this radius perpendicular to this tangent. This radius perpendicular to this tangent. This radius perpendicular to this tangent. So all these are normals. So here the radius is normal to the tangent. So all the normals are meet at point. Meet at point. So that point we can call as the center of curvature. Center of curvature. So this line is perpendicular line. Perpendicular line to the concave surface. Concave reflecting surface, right? So this acts as a normal. This acts as a normal. So as we know, when the light is incident normally or perpendicularly, what will happen? No, means the reflection takes place along the same direction. Along the same direction. Then for example, um, if it is a concave mirror, principal axis. If the light ray incident here, parallel rays we can consider. So incident ray. So as we know, how do we observe the normal? The point where the point at which the line is, sorry, the point at which the light is incident. The light is incident. Here, this is the point of light. This is the point of incident. Where we have to draw the normal? When we imagine a tangent. When we imagine a tangent for 2 points of incidence. 2 points of incidence. So at that point too, we need to draw the normal. We need to draw the normal, right? After that, we know the light ray is reflected. The light ray is reflected. Okay, so angle of incident, angle of reflection. Angle of incident, angle of reflection. So here the dotted line represent the normal. The dotted line represent the normal. The red one is incident ray. The yellow one is the reflected ray. So all the reflected rays which are parallel to the, sorry, all the reflected rays are meet at focus. Then we know if it is the pole, distance between P and F we can call the focal length. F is equal to 2R. Then here it is the center of curvature. Center of curvature. See, all the normals are meet at one point. That point we can call as center of curvature. Center of curvature is perpendicular line, normal. That's why when light is incident or passing through the center of curvature, it reflected along the same direction. Reflected along the same direction. This is the important one. This is the rule number 3. Rule number 3. Rule number 3. Okay, hope understand why the reflected light. Then rule number 4. Rule 4. Rule 4. if light the light incident on a pole, on a pole by making some angle, by making some angle. What happened? The light incident on the pole by making some angle, by making some angle with the principal axis, making some angle with the principal axis, principal axis, principal axis, right? So concave mirror, concave mirror, principal axis, principal axis, here it is the pole. If light ray incident on the pole by making some angle, by making some angle with the principal axis, incident ray, after we know what will happen, reflection takes place, reflection takes place. So if it is, for example, focus center of curvature, center of curvature. So when the light ray incident on the pole by making some angle with the principal axis, it reflected with the same angle, reflected with same angle. In this case, the principal axis acts as a normal, acts as a normal. So even if the light passes through the principal axis, even if the light passes through the principal axis, passes through the principal axis, what will happen? It can reflected in the same direction. No deviation takes place because this principal axis acts as a normal. Here normal line. Normal line. So these are the conditions. These are the rules or conditions for rules obtaining images by a concave mirror. Concave mirror. Okay. Rule 1, rule 2, rule 3, rule 4, rule 4.